In this lesson, we're going to be learning how to calculate the sum of a given sequence in arithmetic progression. Before we go into this calculation, let me tell you the formula for the sum of sequence in arithmetic progression. So the first formula is that sum of the sequence in arithmetic progression is equals to the number of terms over 2. Now let me open this big bracket. Then we have 2a plus, open parenthesis, n minus 1, then close this parenthesis. Then we have common difference. Now let me close this big bracket. So this is the formula for the sum of sequence in an AP. And in this case, you might be given the sum of the sequence, the number of terms, the first term, and you're asked to calculate the common difference. Or you might be given the common difference, the number of terms, the first term, and you're asked to calculate the sum of the sequence. So whichever one you're asked to find, other information will be provided. Now, the second formula is the case where you are given only the first term and the last term. And it states that the sum of the sequence is equals to number of terms in the sequence over 2, then multiplied by the first term plus the last term. Now in this case, the sum of the sequence might be given, the first term and the last term might also be given. You'll be required to find the number of terms, or the number of terms will be given, the first term will be given, the last term will be given. Then you are required to find the sum of the sequence. So whichever parameter you asked to find here, other information will be provided. So let's go into the calculations. And this first question says, the first and last terms of a linear sequence AP are -12 and 40 respectively. If the sum of the sequence is 196, find A, the number of terms, B, the common difference, and C, the 12th term. So we have solution. So we are given the first term as -12, so A is equals to -12. Then the last term, L, is equals to 40. And then the sum of the sequence is equals to 196. So since the first and last term are given, you make use of this formula. Sn is equals to n over 2 multiplied by A plus L. So the sum of the sequence is 196. Then this is equals to, we have to find the number of terms. So this n is what we are looking for now. So we have n over 2 multiplied by, the first term is -12 plus the last term, which is 40. So we have 196 is equals to n over 2 multiplied by 40 minus 12 is equals to 28. Now to clear this fraction here, let's multiply both sides by 2. And this will cancel. 2 times 196 is equals to 392. Then we have equals to 28 multiplied by n. And let's divide both sides by 28. So 28 divided by 28 is 1. We have n here is equals to 392 divided by 28. So you have that the answer is equals to 14. So we have that the number of terms in this sequence is equals to 14. Now let's solve the B part of the question. So we are going to make use of this formula. Now because we have the sum of the sequence, we now know the number of terms, which is 14. We know the first term, so let's use this and find the common difference. Now we have 196 is equals to 14 over 2 into, now a is negative 12, so 2 times negative 12 is negative 24, then plus the number of terms is 14. 14 minus 1 is 13, then multiplied by d. So we have 196 equals to 14 divided by 2 is 7. Then we have minus 24 plus 13d. So we have 196 is equals to 7 times minus 24. So this is 7 times minus 24. So this is equals to minus 168, then plus 7 times 13. So just use your calculator. 7 times 13 is equals to 91. Then we have d. So the next thing we're going to do here is to collect like terms. 196, when this minus crosses here to be plus, so 196 plus 168, we have 196 plus 168. This will give us 364, then equals to 91d. So let divide both sides by 91, and this will cancel. So we have that d is equals to 364 divided by 91. 364 divided by 91, we're going to get that d is equals to 4. So this is the common difference of this sequence. Then C says find the 12th term. We're going to make use of this formula, the formula for the nth term of an AP, which is Tn is equals to a plus n minus 1 d. So we have that the 12th term is equals to, the first term is minus 12 plus the number of terms is 14 minus 1 multiplied by the common difference is 4. So this is equals to minus 12 plus 14 minus 1 is 13, then multiplied by 4. So we have that the 12th term is equals to minus 12 plus, now 4 times 13 is going to be equals to 52. So we have that the 12th term is equals to minus 12 plus 52, something as 52 minus 12, and this is equals to 40. So this is the 12th term in this AP. Let's move to the next question. So the second question is, find the sum of the first 30 odd integers. Then these are the options. So you have solution. Now for you to get this question correctly, you have to know what odd integers mean. You understand? So integers are positive or negative whole numbers, but we have to find the sum of the first 30 odd integers. Now the first 30 odd integers is given by, the first term here is 1, the second term is 3, the third term is 5, the fourth term is 7, the fifth term is 9. Notice that we skipped 2, 4, 6, and 8 because these numbers are even integers, but we are focusing on odd integers, and so on. Then from the question, we're given that the number of terms n is equals to 30. You say find the sum of the first 30 odd integers. So the number of terms in this sequence is equals to 30. So let's take the formula. Sn is equals to n over 2. We have 2a plus n minus 1 multiplied by d. So the sum of terms here, that's what we are looking for, the sum of the first 30 odd integers. So I write that Sn is equals to number of terms is 30 over 2, then multiplied by 2 times the first term here is 1 plus the number of terms is, which is 30 minus 1, then the common difference is 3 minus 1 is equals to 2. So common difference is equals to 2. Or you can say 5 minus 3, which is also 2. 7 minus 5, which is also equals to 2. So, no. So we have 2. Now the sum of these terms is equals to 30 divided by 2 is 15. Multiplied by 2 times 1 is 2. Plus 30 minus 1 is 29. Multiplied by 2. So we have sum of these terms is equals to 15. Then 2 plus 29 times 2. So 2 plus 29 times 2. This is going to give us 60. Then we have Sn is equals to 15 times 60. This is going to give us 900. So we have that the sum of the first 30 odd integers is equals to 900, which is option D. Let's move to the next question. Question number 3. How many terms of the sequence 10, 12, 14, and so on will add up to 190? We have solution. So the first term from the question is equals to 10. The common difference is 12 minus 10, which is equals to 2, or 14 minus 12, which is also equals to 2. This is the common difference. Then the number of terms in that sequence is what we are looking for. Then the sum of the terms is equals to 190. So let's write our formula. The sum of terms is equals to n over 2 multiplied by 2a plus n minus 1 multiplied by the common difference. So from the question, the sum of the terms is equals to 190. We have n over 2 multiplied by 2 times 10 plus n minus 1 multiplied by the common difference is 2. So we have 190 is equals to n over 2 multiplied by 2 times 10 is 20 plus n times 2 is equals to 2n minus 1 times 2 is equals to minus 2. So we have that 190 is equals to n over 2 multiplied by 20 minus 2 is 18. I have 18 plus 2n. So we have 190 is equals to n over 2 times 18 is equals to 18n over 2. Then plus n over 2 times 2n is equals to 2n squared over 2. So we have 190 is equals to 18 divided by 2 is equals to 9. We have n plus 2 divided by 2 is 1 plus n squared. Let me write this. I have n squared plus 9n minus 190 is equals to 0. So this is quadratic equation, and we can solve it by factorization method. What are the two numbers so that when you multiply them you get 190, but when you add them you get 9? So those two numbers are minus 10 and 19. Minus 10 times 19 is minus 190. Minus 10 plus 19 is equals to 9. So we have n squared. Then we are going to replace 9n with minus 10n plus 19n. So we have minus 10n plus 19n, then minus 190 equals to 0. Now let's group this. We have n squared minus 10n plus 19n minus 190 equals to 0. So we have now this n squared minus 10n, something is common here, and that is n. So let's factor it out. We have n squared divided by n is n minus 10n divided by n is equals to 10. So we have plus, between 19n and 190 something is common, and that is 19. So we have 19n divided by 19 is n, then minus 190 divided by 19 is 10. So this is equals to 0. Now this n minus 10 and n minus 10 is common, so we factor it out, n minus 10. Then n times n minus 10 divided by n minus 10, we'll be left with n here. So that's n, then plus here we'll be left with 19. So this is equals to 0. Then we have that n minus 10 is equals to 0, or n plus 19 is equals to 0. So here, let's add 10 to both sides. We have that n minus 10 plus 10 is 0, n is equals to 10. And then from here, let's add minus 19 to both sides. So this will be 0. So we have that n is equals to minus 19. But remember, what we're looking for is the number of terms, and number of terms cannot be a negative number. So we're going to discard this one, and then our answer will be equals to n is equals to 10. So the number of terms in this sequence is equals to 10. Question number 4. The sum of the first n terms of an arithmetic progression is 252. If the first term is minus 16 and the last term is 72, find the number of terms in the series. I have solution. So from the question, we are given that the sum of the first n terms of the progression is 252. So Sn is equals to 252. So if the first term is minus 16, so A is equals to minus 16, and the last term is 72, L is equals to 72. Find the number of terms in the series. So n is equals to, so we're going to make use of this formula. Sn is equals to n over 2 multiplied by first term plus last term. As given in the question, the sum is 252, then equals to, n is what we're looking for. Then we have the first term is minus 16 plus the last term is 72. So we have 252 is equals to n over 2 multiplied by minus 16 plus 72. We have minus 16 plus 72 is equals to 56. So we have 252 is equals to 2 divided by 2 is 1. 56 divided by 2 is going to be equals to 28. Then multiplied by n. Let's divide both sides by 28. This and this will cancel. We have that n is equals to 252 divided by 28 is going to be equals to 9. So you have that the number of terms in this sequence is equals to 9. Then, and the option here is option D. So thank you for watching. Please subscribe to my YouTube channel, like this video, drop your comments and share with your friends. Enjoy the rest of your day and keep learning.